Hi, grade 9s. Today we are going to take a look at linear inequalities. So when we take a look at linear inequalities, one of the things that we do is we consider what an inequality is. So in order to help us, let's see if I can do this. Perfect. So when we see a sign like that, speed limit 65. What does that mean to us? Speed limit 65. Well, what it means is you can drive at a speed no faster than 65 kilometers an hour. It means that you can drive 65 kilometers an hour. You can drive 64 kilometers an hour. You can drive any speed as long as it's not faster than 65 kilometers an hour. And driving any faster than that in that particular area would be illegal. So when we talk about inequalities, there's 4 of them that are really important. And this is something that even grade 11s and 12s sometimes have to spend a little bit of time thinking about. What does less than or equal to mean? What does less than mean? What does greater than or equal to mean? And what does greater than mean? There are 4 inequalities, 2 different signs, and what differentiates the other 2 pieces is either the inclusion or not of the equal sign. So let's look at this right here, less than or equal to. That sign means that you're looking for any number less than 65, but because it says or equal to, 65 is also included. If you take a look at the second inequality, which is just less than, it means that we're looking for any number smaller than 65, but we can't include 65. So it has to be smaller than 65. If we look at this symbol right here, it's greater than or equal to. So that means it can equal the given number, or it can be higher than the bigger number. Okay. And last but not least, we have this one, which is the greater than sign, and that's just any number greater than the given number. Okay. So here are some examples where we are going to define what the variable is, and then we're going to write an inequality to describe each situation. Okay. So the first one is you need to be 18 years of age to buy cigarettes. What's the variable? So a variable is a quantity that can change. For example, if you were to look at the temperature outside, that would be a variable. Because in the morning it might be a little chillier. By lunchtime it might be a little warmer. Close to supper time it'll be warmer yet. And then in the evening the temperature dips back down. The temperature changes during the day. A variable is a number that represents a quantity that can change. So when we take a look at this situation in the first example, you need to be 18 years of age to buy cigarettes. What's the variable? What's the number that can change? The number that can change is the age. The age is the variable. How do we define it? Well, we're going to say let the letter A represent age. When possible, it's a good idea to use a variable that makes sense. If we're talking about age, which of course starts with the letter A good letter to represent age would be A. So this is the define the variable part of the question. The other part of the question is write an inequality to describe each situation. So, what would the inequality be to describe the situation? A is what? Well, it says you need to be 18 years of age to buy cigarettes. Okay, so we're going to put an 18 down here. Which inequality makes sense? Which of these four inequalities make sense? Well, if you can be 18 and buy cigarettes, then the equal to is definitely here. Now think about this. Can a 17-year-old buy cigarettes legally? Can a 19-year-old buy cigarettes legally? Of course, it's the 19-year-old that can. So the inequality here is going to be A is greater than or equal to 18. And with that, we're moving on to the next example. You have a supermarket and it has a 10 items or less line. A 10 items or less line. Otherwise, the grocery clerk will look at you and say, you have to go to a different till. So what's the variable? With all customers at a supermarket, what's the variable? Well, we're going to let I represent the number of grocery items. So I represents the number of items. And I is what? Well, it's 10 items or less. So we're going to put a 10 down there for sure. Now, is 10 items okay? Yeah. So we're going to put an equal to sign there. And it's less. So less means we're going to go the other way. So it's I is less than or equal to 10. I is less than or equal to 10 would be an inequality that represents this scenario. Okay? And there's one more example in this string of questions, and that's part C. There's over 300 students at Hapnot Collegiate. What's the variable? The variable is this. So we're going to let S represent the number of students. In the last two questions, I've used the abbreviated rep. I'm being lazy, or efficient, or both. Instead of writing out represent every single time, I'm just writing down rep. Perfectly acceptable. Okay? So S represents the number of students, and the number in the question is 300. It says there is over 300. If there's over 300, is that above or is that below? Well, over is above or greater than. So the inequality here that we would use is S is greater than 300. We're going to do a couple more examples here, and then it'll be time for you to do some practice questions. Are each of the following numbers a solution to the inequality g is less than 0? So, in order to think about this properly, what I would suggest you do is I would draw a number line. And I'll make the number line black. Here it is. Here's the number line. And let's go ahead and the biggest the numbers get is like 5-ish. And the smallest they get is 5-ish. Negative 5-ish. So there's our number line. So in each of these questions, this one, this one, this one, this one, and this one, we have to ask ourselves, do the numbers satisfy this relationship of g is less than 0? Okay, so let's find 0 on the number line. Here's 0 right here. If it's less than 0, is that to the left of the 0? Or is it to the right of the 0? Answer, it's to the left. So we're interested in anything left of the 0. So in each case, we have to say, okay, is this number in that green area? Is this number less than 0? Is 2 less than 0? No. Is negative 3 less than 0? Yes. Is 4.8 less than 0? No. Is negative 0.1 less than 0? Yes. Is 0 less than 0? No. 0 is the same or equal to 0, but it's not less than 0, so the answer is no. So the number line that we drew, that we used, is a visual tool that helps us organize our thoughts when we're doing a question like this. It's not necessary for this example, but it will be necessary for the next example. The next example asks us to graph these inequalities on a number line. So I have 4 number lines here. I might as well label each of them A, B, C, and D. So let's start off with A. A is less than 2. A is less than 2. So I'm going to put a hollow dot at 2. It's hollow because it doesn't equal 2. And if it's less than, do we go left of that point or right of that point? We go left of the point. So we're going to shade, well, not shade, we're going to draw an arrow to the left of that point. And any point, any number that's to the left of 2 or less than 2 satisfies the inequality. Okay? The next one we have is this one. This one's different because the letter comes second. So if you want, you can rewrite this. So if you rewrote it, you could write the letter first. You could see the pointy end of the inequality is beside the B. So that's still the case. And we have B is less than or equal to 4. So we need to find 4. And it's equal to 4, by the way. So instead of a hollow dot, we're going to have a filled in dot for this one. And now we're going to look at B is less than or equal to this. So it's everything left or right. What's less? It's left. So it's everything to the left of that point that's included in this inequality. There we go. When you're doing these for homework, if you don't have these number lines, you're going to just have to make one yourself. And if you do that, just make sure to include a scale. The scale are these numbers down here. Make sure that those numbers are on your number line so it's clear what numbers you're talking about. And we're on to the next one. The next one is another one where the letter comes second. So we can rearrange it. And the big part is beside the C, so we'll replicate that and put C is greater than or equal to -3. Where does -3 live? -3 lives right here. Now, C is greater than or equal to that, so it's everything to the right. And there we go. That represents C is greater than or equal to -3. And finally, we have D is greater than or equal to 3.5. 3.5 is 3.5. 3.5 lives right here. And if it's greater than or equal to, it is a solid dot because it's equal to, and because it's greater than, it's everything to the right. And that's all she wrote. For practice, you'll be working on questions 3 to 15 on pages 292 to 293 of your textbook.